you so much. Today, I'm so happy to present my presentation, which is under the title Skew-Homogeneralized Derivation of Rings. The main purpose of this paper is to introduce the definition of Skew-Homogeneralized derivation, respect Skew-anti-homogeneralized derivation, and homogeneralized Skew derivation, respect anti-homogeneralized Skew derivation of ring. This article divided into three sections. In first one, we emphasize on the main definition. And in the second section, we study Skew-Homogeneralized derivation H of a ring R, while in the final section focus on rings amidst homogeneralized Skew derivation H satisfy certain identities. Now it's time to learn something about the subject. One of the natural equation of ring theory is to determine condition implying commutativity of the ring. During the last 2 decades, the commutativity of associative ring with the derivation have become one of the focus point of several authors, and significant work has been done in this direction. Basically, the study of derivation was initiated during the 1950s and 1960s. Derivation of ring got tremendous development in 1957 when the Posner established two very result in the case of prime ring. A considerable amount of work has been done in this on derivation and related map during the last decades. Indeed, in reference 12, Asma and others provide that R is semi-prime ring, U a non-zero ideal, and H is a homoderivation of R, which is 0 power valued on U. If H is strong commutativity preserving on U, then U subset of the center of R. Actually, the study of commutativity preserving started in 1976 when the Watkins published his paper dealing with the bijection linear commutativity preserving matrix, maps on matrix algebra. On the other hand, Nadim Ar-Rahman and other provide that R is a two-Taussian free semi-prime ring, U I non-zero ideal, H homoderivation of R. If the condition hold this, the condition this in the center of R, then ideal in the center of R. And Abdul Karim in reference 8 study the commutativity of three prime rings, near rings, admitting homoderivation which satisfies certain differential identities on near ring. Homoderivation has diversity notions in agreement with the references 10. The effect of homoderivation on ideal studied by Refi and Muthanna. They provide that U is a non-zero left ideal in a prime ring R. It missed homoderivation H, which is 0 power valued on U, satisfy the relation, then R is commutative. Also, Ahmed Kinani and others showed R is a star prime ring and U a non-zero ideal of R if X in R and X centralizes U ideal, then X belong to the center of R. Asma and others pointed out that R is any ring with no non-zero central ideal if H from R to R is 0 power valued. CE homoderivation, i.e. central extended homoderivation, then H is additive. In this paper, our aim is to introduce and explore the nature of Skew-Homogeneralized derivation and homogeneralized Skew derivation of rings and make some basic derivation. During my work, I depended on some basic concept. R always represent an associative ring and Z of R. It is center for all xy element of R. We write the bracket for xy yx minus xy and x circle y for the anticommutator. Also make some other identities. Recall that R is semi-prime if RAR equals 0 implies A equals 0, and R is prime if ARB equals 0 implies either A equals 0 or B equals 0. Every prime is semi-prime, but the converse is not true always. Furthermore, R is said commutative if satisfy this relation for all xy in R, and ring R is said to be anti-commutative if xy equal minus yx for all xy in R. A ring R is said to be n-Tauschen free if for x in R and x equals 0 implies that x equal 0. Let R be a commutative ring with identity. Recall that a proper ideal of R is called semi-prime if A in R and A square in U implies A in U. Then a proper ideal U of R to be weakly semi-prime if A in R and A square not equal 0 belong to U implies U A in U. An element A in R is called a weak zero divisor if there exist another elements R and S in R with RAS equals 0 and the multiply RS not equal 0. A map D from R to R is to be commuting on R if the bracket equals 0 holds for all x in R. It is said that a map D is centralizing in the same bracket, in this case belong to Z of R. In additive mapping, D from R to R is called a derivation if the Lipin's rule satisfy holds for all xy in R. Also, an additive D capital from R to R is called generalized derivation if there exists an additive mapping D on R such that satisfy this relation. In 2000, As-Sufi defined a homo derivation of R as an additive mapping H satisfy this relation for all xi in R. It is clear that a homo derivation H is also derivation if H of x, H of y equal 0. The mapping F from R to R preserves S if f of S subset S. A mapping F from R to R is 0 power valued on S if S the reverse S and if for each x in S there exists a positive integer n of x greater than 1 such that satisfy this relation. Furthermore, mapping H from R to R is strong commutativity preserving S CP on S if satisfy this relation. Now it's time to present the main definitions. First definition, let R be a ring and alpha be automorphism mapping of R. In additive mapping, H from R to R is called a Skew-Homogeneralized derivation of R if satisfy this relation. Skew anti-homogeneralized derivation of R if satisfy this relation. we find here the swap of position of the elements X and Y. In definition 2, let R be a ring. In additive mapping, H is called a homogenealized CQ derivation of R if satisfy this relation, and anti-homogenealized CQ derivation of R if satisfy this relation. In both cases, H, small h, from R to R is homo CQ derivation of R, i.e. satisfy this relation, and alpha is automorphism mapping of R associated with H small for all xy belong to ring R. Sorry, for to become more close to the definition, we put the following example. Consider the additive mapping H from R to R defined by this relation mu here and endomorphism on R. Now we test whether H is CQ homogenealized derivation of R or not. Start Y depend the definition of CQ homogenealized derivation of R, and now substitute in the left side we obtain this result, and this is of right side, and in the left side also we will give the sum result. It's clear H is CQ homogenealized derivation of R. Similar if I need test CQ anti-homogenealized derivation of R. For homogenealized CQ derivation, this formula, we apply similar technique which used in the previous example with define H of R by this formula and small h by this formula where also mu is endomorphism of R. To prove the main theorems, we need some lemmas. This is lemma 1, R semi-prime ring, and this satisfy this bracket. Also, lemma 2, R semi-prime ring, H from R to R be additive mapping if H of X times X equals 0 or H of X equals 0 implies this H equal 0. Lemma 3, R prime ring, every intersection of prime ideals is sim prime. Conversely, prime ideal is intersection of the prime ideals. In section 2, which focus on homogenealized CQ derivation of R, we begin with the following result. R sim-prime ring admits homogenealized CQ derivation H, which is zero power valued on R satisfy this relation, then H of R equals 0. And R semi-prime ring admits also for H, which is in this case strong commutativity preserving on R satisfy the same relation. In this theorem, we find R is commutative. R semi-prime and H also in this theorem is strong commutativity preserving of R satisfy this relation, then we obtain the identity. One can prove the following corollary using the same technique as above. Here, R prime ring with characteristic different from 2. H is homo CQ derivation on R, which is strongly commutativity preserving on H, and H is 0 power value on R. Satisfy this relation, then either R is commutativity or R square equal 0. Theorem 5, R sim prime and H is 0 power value on R satisfy H of R circle R equal R circle R, then H of R equal H R capital and small equal 0. Sorry, here in this, in the next theorem, we consider homoscue derivation, which means H is 0 power valued on R, and use similar argument as in theorem 2.5. We show that this also H capital and small equal 0 in the theorem 6. Theorem 7, RBSM prime admits H, which is 0 power valued on R, satisfy the bracket H of X, H of Y equals 0 for all X, Y, and R. Then either H is commute of R or H of H small, which means homoscue derivation of homogeneralized skew derivation of R equal 0. Theorem 8, let R be a ring. It must H satisfy this relation, her bracket HRR, and in the left side R circle R. If R prime ring in this case, then H of R equals 0 and R is anti-commutative. In the final section, we examine a CQ homogeneralized derivation or ring. We begin with the result. Let LR be integral domain with characteristic not equal to, and let alpha be automorphism mapping of R, and U be an ideal of R. If H CQ homogeneralized derivation such that H square of R equals 0, then the ideal U is weakly semi-prime ideal.
Mehsin, you have a couple of minutes.
Yes. Also, you can use same technique with theorem 3.2 and in theorem 3.3 R2 tauschen free semi-prime ring without zero divisor of 0, automorphism, and with the condition, then we can get U weakly semi-prime ideal and R has a weak 0 divisor. Theorem 4, corollary 4 by some way. And theorem 5, R2 tauschen free, and the H satisfy this relation, then H of R equal 0. Theorem 6, corollary 6, R2 tauschen free, semi-prime ring, U in ideal, alpha automorphism, H CQ homo derivation. If R admits to satisfy this relation, then H of R equal 0. Finally, I closed my presentation by list of references which I used in my work. Finally, thank you so much for your listening to me. Thank you.